another video in the series of basic electronic components. Now, we've previously discussed about resistor. Now, we'll have a brief discussion about capacitor. So, we'll try to familiarize ourselves with the capacitor. So, this video is specifically, I think, for freshman ECE student. This will be a very basic discussion. So, I'll be discussing first the structure, then the symbol, the unit of capacitance, the function of a capacitor, of course, and also I'll give an example kung saan ba ginagamit or ang use ng capacitor. So, first of all, ito, if you're not yet familiar, this is an actual picture of a capacitor. So, actually, maraming klase ng capacitor. So, ito yung very common, I would say, na makikita natin at magagamit natin ng capacitor. So, ganito yung itsura niya. And, yung value ng capacitance nitong capacitor na to is actually makikita mo na sa packaging niya. Sa labas, makikita mo naka-print out dun yung value. So, pati yung maximum voltage na kayang i-hold nitong capacitor is naka-specify din dun sa labas ng capacitor. So, in this case, example natin, 47 microfarads yung value niya and 400 volts yung maximum voltage that it can withstand. Then, ang capacitor, just like a resistor, is also a passive element. Okay? And capacitor has two terminals. It has a positive and a negative. So, pag bumili ka naman, nakalagay naman dun, makikita mo kung anong terminal, anong side yung positive and negative. So, ito yung may white na strip na may negative, yun ang negative side. So, yun yung i-connect natin sa negative. Then, isa yung positive. Usually, mas mahaba yung paa ng positive. Pero, syempre, bukod dun sa indication na yun, may nakasulat naman na negative sa gilid. May white strip. So, now, structure ng capacitor. So, ito yung picture ng structure ng isang capacitor. So, sa loob, we have two metal plates or two conductors. And in between these two conductors is tinatawag nating dielectric. So, yung ginagamit na material dito sa mga plates, which is conductor, is usually aluminum foil. And for the dielectric naman, iba-iba. Depende sa type ng capacitor. So, but basically, insulator yung nasa pagitan nitong dalawang metal plates natin. It could be air, glass, ceramic, plastic, paper. But basically, mga insulator yung nasa gitna ng dalawang metal plates. So, basically, ganyan yung itsura ng capacitor. Yung structure ng capacitor. Okay, and now, one of the basic formulas of capacitance that we use is itong tinatawag natin na sayad. Well, that's just actually a mnemonic. But syempre, hindi naman talaga siya yung tawag sa formula na to. Para lang matandaan nyo yung itsura ng formula pag sinabing capacitance. But basically, mas magandang maintindihan natin. So, capacitance is equal to epsilon times A over 4 pi D. So, ano ba itong mga to? So, yung epsilon, yung parang ER, is what we call the relative permittivity. So, yung value nitong relative permittivity na to is dependent sa dielectric na ginamit natin sa ating capacitor. So, sabi nga natin, meron tayo iba't ibang types ng dielectric na ginagamit. Depende sa type ng capacitor. So, yung permittivity na gagamitin natin depende kung ano ginamit natin. Dielectric, may kanya-kanya kasing permittivity itong iba't ibang materials na to. So, depende talaga sa material. Then, A is the area or the surface area ng plates natin ay yung conductors na pinag-usapan natin kanina. Then, D is the distance between the two plates. So, meron nga tayong, di bang, parang sinandwich natin with two plates yung dielectric. So, yung distance itong dalawang dielectric na to, yun yung D dun sa formula. Na C is equals to EA over 4 pi D. Now, we can notice in the formula that the capacitance is directly proportional to the surface area and inversely proportional naman siya sa distance between the two plates. So, habang lumalaki yung surface area ng capacitor natin, habang mas malaki yung capacitor natin, mas malaki din yung capacitance that it can hold. And since inversely proportional siya sa distance, the more na pinaglalapit natin itong two plates na to, the more na lumalaki yung capacitance. Kabaliktaran naman pag pinaglayo natin, liliit yung capacitance. So that's the relationship between capacitance, its surface area, and the distance between these two plates. Okay? Now, I just also want to show you yung symbol naman ng capacitor pagdating sa mga schematic diagram. So, paano natin siya dinadraw sa schematic diagram? So, basically, ito yung kanyang itsura. Two parallel lines or pwedeng isang straight line at isang curved line. So, dito sa may curved line, negative yung may curved line na side, positive yung straight. Okay? So, ito yung symbol na ginagamit natin pag i-draw natin siya sa schematic diagram. And also, the unit we use for capacitance ng isang capacitor is what we call farad, which is designated by the symbol F. Okay? Bakit F? But, itong farad nito is actually too big. Masyadong malaking value nito. So, usually, ang may encounter natin is microfarad, nanofarad, picofarad. So, nandito sa table na to, yung prefix at yung equivalent niya na weight. Kung 10 raised to negative 12, that's picofarad, 10 raised to negative 9 for nanofarad, and 10 raised to negative 6 for microfarad. So, ito yung microfarad, nanofarad, and picofarad yung mga usual nating makikitang value. Milli and kilofarad, hindi siya usual, but I think for supercapacitors, masyado na kasing malaki yung value na yun. Okay. So, now that we've discussed yung symbol, itsura, structure, unit, formula ng capacitance ng isang capacitor, ano nga ba ang gamit or function ng isang capacitor? So, basically, ang pinaka-function ng capacitor is to store and release the electric charge. So, basically, yung pinaka-ginagawa niya, mag-store siya ng charge, i-release niya at a certain time. So, sa pinaka-basic function na to, nagkaroon ng different and several applications ang capacitor. So, it would seem simple, store and release electric charge, pero its use pagdating sa electronics, mga circuits, is very wide ng application ng capacitor. Yung simple function na to, depende kung paano natin ikakabit sa circuit, it would serve different functions and be used in different applications. And also remember that a capacitor passes AC but blocks DC signal. And it could also filter out AC. Depende kasi kung paano natin i-connect sa isang circuit, kung connect ba siya papunta sa ground. So, depende talaga sa application. But basically, ang capacitor, pinapadaan niyang AC at binablock niya ang DC. So I just want to show you, well, this is just like a meme kung paano daw nakakadaan ang AC at hindi nakakadaan ang DC sa isang capacitor. Why AC current passes through the capacitor? So this is not an actual legit na explanation, but just for visual aid para tumatak sa inyo kung paano nagbe-behave ang AC at DC sa isang capacitor or through a capacitor. So this one, let's look at it, kung paano daw nakakadaan ang AC. Well, don't take this seriously because this is just for visual aid, okay? But para hindi nyo makalimutan why an AC passes through capacitor. Okay? Para tumatak lang sa isip natin, okay? Don't take it seriously, but try to give you some mnemonics then for memory aid. I don't know if you've heard about this because I learned this sa review center. Tinatawag natin Casio and Disco. So Casio, again, this is just for memory aid para lang mas tumatak sa inyo kung anong behavior ng AC at DC pagdating sa capacitor DC. So meron tayong dalawang signal. Meron tayong AC, Casio. Pag DC naman, Disco. So pag-usapan muna natin ng AC. Kapag AC ang pinag-uusapan natin, let's use the mnemonic Casio. AC. So, Casio, AC. Anong behavior ng AC sa capacitor? Capacitor. So, capacitor acts like shorted kapag AC ang pinag-uusapan natin. E paano naman kapag DC na ang pinag-uusapan natin? Capacitor acts like an open circuit. Again, kapag AC ang pinag-uusapan natin, capacitor shorted. Pag DC naman, disco, capacitor open. So, discuss ko na rin yung IO tsaka IS. Actually, para sa inductor yan. Kapag naman inductor sa AC, yung inductor, kabaliktaran, para siyang open circuit. Pag naman DC yung pinag-uusapan natin, inductor shorted. Baliktaran lang siya. So, this is just a mnemonic. Don't take this seriously. So, again, AC, Casio, DC, Disco. Disco, Casio, Disco, Casio, Disco, Casio, Disco, Casio, Disco. So, match lang natin. Capacitor pinag-uusapan natin. Ano susunod na pinakamalapit na letra? From left to right, S, shorted. DC pinag-uusapan natin, capacitor. Anong pinakamalapit na letra? From left to right, O, open. So again, this is just used to serve as memory aid. Okay? Going back sa capacitor. So, yun nga, as we have said, the function ng capacitor is to store and release electric charge and also to pass AC but block DC. So, let's give an example kung saan ginagamit ang capacitor. So, one example is a conditioning ng power supply. Okay, so this is the picture. Sa power supply, meron tayong transformer, then meron tayong diode, which acts as a rectifier, then may capacitor. So, anong function ng capacitor dito? Kasi, diba yung source natin will come from an AC supply. Usually sa power outlet natin, sa outlet natin, comes yung AC supply natin. Nadadaan sa transformer to step it down to a lower value. Then, nadaan siya sa bridge rectifier, which is made up of diodes. Pero pag lumabas kasi siya sa bridge rectifier, hindi pa talaga siya totally DC. Kasi ang goal, diba natin, yung AC na signal natin from our source is to turn it into a DC supply. So, paglabas niya ng bridge rectifier, hindi pa talaga siya filtered out. Kasi parang ang ginagawa lang ng diode or nitong rectifier is tinatanggal niya yung negative half ng cycle. So, parang natitira na lang every positive cycle. So, yung first positive cycle coming from yung sa isang path ng diode will create positive half. Then, pagdating sa negative half nun, magiging reverse bias na siya. So, makakat yun. Pero at that time, positive half naman ng isang path diode ang makikreate. Tapos, pagdating naman sa negative half nun, makakat siya. So, parang natitira is mga positive halves. Pero kung imagine natin yung itsura nun, nawala lang yung negative half, naiwan yung mga positive half. Pero hindi pa rin natin totally na-achieve yung DC na smooth na gusto natin. So, we're going to use a capacitor para ma-filter out pa tong signal na to to become smoother. So, parang tinatawag siyang smoothing capacitor. So, I'll try to illustrate. Hindi pa rin talaga siya smooth. Para siyang pulsating DC pa din. So, gusto nating matanggal yung mga interval na to kung saan bumababa yung signal. So, since ang capacitor, function niya is to store and release. So, at these points, or at this time, pwede natin gamitin yung capacitor para mag-release siya ng signal. Sa time na to, kung saan bumababa pa yung signal natin. So, instead na ganyan, ang magiging itsura natin is smoother. Although may next stage pa tayo para mas ma-regulate pa yung signal. Pero, pag dumaan siya ng capacitor, basically magiging smoother siya. So, basically, this is how it would look like. So, paglabas niya ng bridge rectifier, ganun, positive half lang yung natira. Nawala na yung negative half. So, yung blue yun, na signal. Pero, hindi pa siya smooth. Hindi pa ito yung gusto natin. So, gagamit tayo ng capacitor to smooth out pa. So dun sa mga points, kung saan nagpo-fall pa yung voltage, magsusupply yung capacitor, magre-release ng electric charge yung capacitor. Okay? So, I've given you a simple example, and the most basic or common example of the application of or use of a capacitor. So, there are other uses or applications in other circuits, complicated circuits, but for introduction of capacitor, ito muna yung pinaka-basic that I want to discuss to get you familiarized muna what is a capacitor, how it works. Then, when we advance dun sa mga susunod na lecture videos, dun na lang natin na-explain kung ano pa ba yung function ng capacitor sa mga scenarios na yun. Basically, you know now kung ano yung itsura, symbol, unit, capacitance formula, and pinaka-basic na function na ginagawa niya. This is just a basic video intended for freshmen ECE students. Okay? So, that's all, and thank you for listening.